Welcome back to the exam walkthrough. We're going to be doing another question on moments, and this one's going to be from June 2024, question number 18. I'm showing you the question right here. This is part A, and this is part B. To check the examiner report and the mark scheme, you can go to the end of the video. So it says a lorry is crossing a bridge and the bridge is supported by two columns as shown. Forces P and Q act on the bridge from the columns, and the center of gravity of the bridge is at its center. At a particular time, the lorry is 35 centimeter from point X. A simplified diagram showing the positions of the forces on the bridge is shown below. Calculate the magnitudes of forces P and Q. You should take the moments about X, force from lorry, and then the weight of the bridge is given to us. Okay, so if the center of gravity of the bridge acts from the center, then we can say that the bridge is going to be uniform bridge. Okay, and then they've given us the force of the lorry and the weight of the bridge, so I'm going to put that right there. So this is going to be 4.2 times 10 to the raised power of 5 newtons, and this is going to be 9.8 times 10 to the raised power of 5 newtons. This question is actually really helpful because they already tell you where to take the moments from. So we're supposed to take the moments about X. Okay, and another very important thing is the bridge is in equilibrium. So the bridge is in static equilibrium. Static equilibrium. Static just means it's not moving, so it's in equilibrium. Okay, it's in static equilibrium. So when static equilibrium is there, we have two things that are gonna be happening. Okay, the first is the anti-clockwise moment is equals to the clockwise moment, and the second thing is that the resultant force is going to be equals to 0. Or another way that people write this is that the upward forces are equal to the downward forces. So using both of these, we can find the values of P and Q. This is kind of like the rule that works for every question. If you use both of these equations and just work around them, you will eventually get the answer. So these are the two equations we're going to be using. Anti-clockwise moment is equals to clockwise moment. Let's write the moment down. And then the net resultant force is equal to 0, or the upward forces are equal to the downward forces. So we're going to be working about both of these. So first let's consider the anti-clockwise moment is equal to the clockwise moment. And I'm going to be writing I'm going to be writing my moments about the pivot X. Okay, I'm just writing it down. Why not? So let's just see the moments that are going to be acting. So we can see that that's our pivot right there, point X, and the forces whose line of action. Listen to me very carefully. This is the line of action. It's like an imaginary line. Okay, the forces whose line of action passes through the pivot. You can see the line of action is like an imaginary extended line. The forces whose line of action passes through the pivot are going to have their moment equals to 0. So the moment due to force P is 0, so we ignore it. I hope that's clear. The next point. We have three forces here, and each of them have a moment. Moment due to the lorry, moment due to the bridge, moment due to force Q. So we can see these two moments are going to be clockwise, and this is going to be the anti-clockwise. Okay, so I can write clockwise moment is equals to anti-clockwise moment, and then I can write the moment due to the lorry plus the moment. It should actually be T because we say in physics torque, but it's fine. Plus bridge should be equals to the moment due to the force Q. Right, now I'm going to plug in the value. Now before I put the values, I also want to make one thing clear. The moment or the torque is equals to force times the perpendicular distance. Okay, so we have been given all the distances and it should become very easy now. So here I have the equation. You can just check if the distances and everything is correct. And now we will just solve it algebraically and we'll get the answer. So we're going to get the value of force as 6.125 times 10 to the raised power of 5 newtons. Okay, so that's clear. So that's going to be the answer to the value of Q. Force Q is going to be, we can write it as 6.13 times 10 to the raised power of 5 newtons. Okay, that's the first thing. Now, the second thing we can do Now there are many ways you can do this. You can also take the moments about this where the force Q acts, and you can find force P as well. And you can take moments actually about any point. You can take this point as the pivot, and you can take moments about this point, and then you can take moments about here as well. But the easiest way to solve this is to use upward forces are equal to the downward forces. Okay. Or you can also use the net resultant forces equals to 0. Both are the same thing. So I'm going to use the upward forces are equals to the downward forces. So I'm going to write 4.2 times 10 to the raised power of 5 plus 9.8 times 10 to the raised power of 5 is equals to the two upward forces, which one of them we found, 6.13 times 10 to the raised power of 5 plus force PQ. The force P. Okay. So we find the force P now. So we're going to get the final answer 7.87 times 10 to the raised power of 5 newtons, which is going to be the value for force which is acting at P. Force P. So we're going to write it as 7.9 times 10 to the raised power of 5 newtons. Alright, so this is the forces that are acting, force P and Q. This was a pretty decent question. And I think part B is the next one that we can go with. It's a explanation question. So it says to us here that explain why the force Q increases as the lorry moves across the bridge. So I've brought the diagram back again. And what this question is saying is the lorry is going to be now that moves across the bridge. So the lorry is going to be somewhere here now, right? So it's going to be right over here. Let's say it's here, so it travels much further. So instead of the force from the lorry being here, now the force from the lorry is right over here. Force from lorry. Now, what we're going to do now is we want to explain why the force increases, right? Force Q. Why does this force Q increases if the distance of the lorry increases? Basically, that's the question. So we can use the principle that we used before, which is that the anti-clockwise moments are equal to the clockwise moments. Okay. And we will take the pivot as point X. Okay, the point X we'll take as the pivot. And we have three moments here. The moment due to the force from the lorry times the distance from the lorry to the pivot, and then let's say distance d1, plus the weight of the bridge times the distance from the weight of the bridge to the point X, so let's say d2, and then is equals to the force Q times the distance from force Q to the point X, d3. Now I want you to just ignore this because the weight of the bridge and this distance, they do nothing. They're not going to change at all. What is changing is the distance. Okay, the distance from the lorry to the pivot. So at first the lorry was right over here. The distance was 35. Now the lorry is all the way here, or it's much further from that position. So that distance has increased now. So this distance has increased, which means the total anti-clockwise moment increased. It's like when you add two numbers and one of the number becomes bigger, the overall value becomes bigger. Now, to ensure that anti-clockwise moment is equals to clockwise moment, the force Q will increase and that distance from force Q to point X will remain the same. It will remain 120. This value will remain as 120. Okay, if you calculate the total distance here, it will be 120. That won't change. You can't magically move around these things, right? You can't move those columns further, okay? Or the bridge, you can't change that. So that will remain as 120. This distance will obviously remain same and this will remain same. So the force FQ or the force Q will increase to make sure the anti-clockwise moment is equal to clockwise moment. Okay, so that's going to be the answer to that. So while I was writing the answer, I realized I made a little bit of a mistake here. This is actually the other way around. This is going to be the clockwise. and this is going to be the anti-clockwise, right? Otherwise the concept is the same. Okay, everything else is fine. So just look out for that one. When I was writing the answer, I spotted that one. Okay, anyways, so let's go back to the answer. So distance from X to the lorry increases, and then the moment due to the lorry is going to increase. The total clockwise moment increases, so the anti-clockwise moment must also increase, because the sum of moment is equals to 0, or the anti-clockwise moment is equals to clockwise moment. So the moment due to the force Q must also increase. So the force Q increases because the distance remains the same from Q to X. So hope that answer makes sense. And yeah, now I'll show you the mark scheme and the examiner report, and we'll end this video then.